Hello everyone, welcome to Cloud Pedagogy. In today's session, we will understand AWS monitoring tool which is called AWS CloudWatch. The great thing about CloudWatch is that all you need to get started is an AWS account. It is managed service which enables you to focus on monitoring without managing any underlying infrastructure. For example, our student directory application is built with various AWS services working together as building blocks. It would be difficult to monitor all of these different services independently. So, CloudWatch acts as one centralized place where metrics are gathered and analyzed. You already learned how EC2 instances post CPU utilization as a metric to CloudWatch. Different AWS resources post different metrics that you can monitor. Many AWS services send metrics automatically for free to CloudWatch at a rate of 1 data point per metrics per 5-minute interval. You don't need to do anything to turn on that data collection. This by itself gives you visibility into your systems without you needing to spend any extra money to do so. This is known as basic monitoring. For many applications, basic monitoring does the job, like in our student directory application. For applications running on EC2 instances, you can get more granularity by posting metrics every minute instead of every 5 minutes using a feature like detailed monitoring. Detailed monitoring has an extra fee associated with it. We'll just break down the metrics. Each metric in CloudWatch has a timestamp and is organized into containers called namespaces. Metrics in different namespaces are isolated from each other. You can think of them as belonging to different categories. AWS services that send data to CloudWatch attach dimensions to each metric. A dimension is a name or value pair that is part of metric's identity. You can use dimensions to filter the results that CloudWatch returns. For example, you can get statistics for a specific EC2 instance by specifying the instance ID dimension when you search. But you may get doubt how to set up the custom metrics if I want to. Let's say for your student directory application, you wanted to record the number of page views your website gets. How would you record this metric to CloudWatch? It's an application level metric, meaning that it's not something that EC2 instance would post to CloudWatch by default. This is where custom metrics come in. Custom metrics allows you to publish your own metrics to CloudWatch. If you want to gain more granular visibility, you can use high resolution custom metrics, which enables you to collect custom metrics down to 1 second resolution. This means you can send 1 data point per second per custom metrics. Other examples of custom metrics are web page load times, request error rates, number of processes or threads on your instance, amount of work performed by your application. Note that you can get started with custom metrics by programmatically sending the metric to CloudWatch using the Put Metric Data API. Next, we'll understand the CloudWatch dashboards. Once you have provisioned your AWS resources and they are sending metrics to CloudWatch, you can then visualize and review that data using the CloudWatch console with dashboards. Dashboards are customizable home pages that you use for data visualization for one or more metrics through the use of widgets, such as a graphic or text. You can build many custom dashboards, each one focusing on a distinct view of your environment. You can even pull data from different regions into a single dashboard in order to create a global view of your architecture. CloudWatch aggregates statistics according to the period of time that you specify when creating your graph or requesting your metrics. You can also choose whether your metric would just display live data too. Live data is data published within the last minute that has not been fully aggregated. You are not bound to using CloudWatch exclusively for all your visualization needs. You can use external or custom tools to ingest and analyze CloudWatch metrics using the Get Metric Data API. As far as security goes, you can control who has access to view or manage your CloudWatch dashboards through IAM policies that get associated with IAM users, IAM groups, or IAM roles. Next, we'll get to know CloudWatch logs. CloudWatch can also be the centralized place for logs to be stored and analyzed. For this, we will use CloudWatch logs. CloudWatch logs can monitor, store, and access your log files from applications running on Amazon EC2 instances, AWS Lambda functions, and other sources as well. CloudWatch logs allows you to query and filter your log data. For example, let's say you are looking into an application logic error for your application, and you know that when this error occurs, it will log the stack trace. Since you know it logs the error, you query your logs in CloudWatch logs to find the stack trace. You also set up metric filters on logs which turn log data into numerical CloudWatch metrics that you graph and use on your dashboards. Some services are set up to send log data to CloudWatch logs with minimal efforts like AWS Lambda. With AWS Lambda, all you need to do is give the Lambda function the correct IAM permissions to post logs to CloudWatch logs. Other services require more configuration, of course. For this example, if you want to send your application logs from an EC2 instance into CloudWatch logs, you first need to install and configure the CloudWatch logs agent on the EC2 instance. The CloudWatch logs agent enables Amazon EC2 instance to automatically send log data to CloudWatch logs. The agent includes the components like a plugin to the AWS command line interface that pushes log data to CloudWatch logs, a script that initiates the process to push data to CloudWatch logs, and then a cron job that ensures the daemon is always running. After the agent is installed and configured, you can then view your application logs in CloudWatch logs. We'll see different terminologies behind the CloudWatch logs. Log data sent to CloudWatch logs can come from different sources. So it is important you understand how they are organized and the terminology used to describe your logs. Log event. A log event is a record of activity recorded by the application or resource being monitored, and it has a timestamp and an event message. Log stream. Log events are then grouped into log streams, which are sequences of log events that all belong to the same resource being monitored. For example, logs for an EC2 instance are grouped together into a log stream that you can then filter or query for insights. Log groups. Log streams are then organized into log groups. A log group is composed of log streams that all share the same retention and permission settings. For example, if you have multiple EC2 instances hosting your application and you are sending application log data to CloudWatch logs, you can group the log streams for each instance into one log group. This helps keep your logs organized. Next, we'll see how to configure a CloudWatch alarm. You can create CloudWatch alarms to automatically initiate actions based on sustained state changes of your metrics. You can configure when alarms are triggered and the action is performed. The first thing to decide is what metric you want to set up an alarm for. Then you define the threshold at which you want the alarm to trigger. Next, you define the specified time period of which the metric should cross the threshold for the alarm to be triggered. For example, if you want to set up an alarm for an EC2 instance to trigger when the CPU utilization goes over a threshold of 80%, you also need to specify the time period the CPU utilization is over the threshold. You don't want to trigger an alarm based on short temporary spikes in the CPU. You only want to trigger an alarm if the CPU is elevated for a sustained amount of time. For example, if it is over 80% for 5 minutes or longer when there is a potential resource issue. Keeping all that in mind, to set up an alarm, you need to choose the metric, the threshold, and the time period. An alarm has 3 possible states. The OK state refers the metric is within the defined threshold. Everything appears to be operating like normal. The alarm state, the metric is outside of the defined threshold. This could be an operational issue. The next state, insufficient data. The alarm has just started and the metric is not available, or not enough data is available for the metric to determine the alarm state. An alarm can be triggered when it transitions from one state to another. Once an alarm is triggered, it can initiate an action, and actions can be an Amazon EC2 action, or maybe auto scaling action, or a notification sent to Amazon simple notification service. But how do you think we use CloudWatch alarms to prevent and troubleshoot issues? CloudWatch logs uses a metric filters to turn the log data into metrics that you can graph or set an alarm on. For example, for our student directory application, let's say you set up a metric filter for 500 error response codes. Then you define an alarm for that metric that will go into the alarm state if 500 error responses go over a certain amount for a sustained period of time. Let's say if it's more than 500 error responses per hour, the alarm should enter the alarm state. Next, you define an action that you want to take place when the alarm is triggered. In this case, it makes sense to send an email or text alert to you so that you can start troubleshooting the website, hopefully fixing it before it becomes a bigger issue. Once the alarm is set up, you feel comfortable knowing that if the error happens again, you will be notified promptly. You can set up different alarms for different reasons to help you prevent or troubleshoot operational issues. In the scenario just described, the alarm triggered an SMS notification that went to a person who looked into the issue manually. Another option is to have alarms trigger actions that automatically remediate the technical issues. For example, you can set up an alarm to trigger an EC2 instance to reboot or scale services up or down. You can even set up an alarm to trigger an SNS notification, which then triggers an AWS Lambda function. The Lambda function then calls any AWS API to manage your resources and troubleshoot operational issues. By using AWS services together like this, you respond to events more quickly. I hope you are very much interested in doing and learning about it. Hope it was interesting and helpful. See you again in my next video. Until then, take care.